digital electronics principles. So in this video, we are going to see about the half adder using basic and universal gates. So this experiment we are going to do with IIT Bombay Virtual Lab. So if I go into the respective website, so here we have like a list of experiments. In that I'm going to do now half adder using basic gates. So this is how we will be doing our experiments using our trainer kit, but the same way we are going to do that in a virtual lab. So if I go for the simulation, click here. So this is how we are going to have our breadboard structure in the trainer kit. So for the IC, we are in need of power supply, inputs as well as outputs. So with this, we are going to see the working principle of individual gates. So for half adder using logic gates, we need two IC components. The components are IC7408, which is AND gates, and IC486, which is XOR gate. So with this two gate, I've just dragged it and placed in the breadboard. Okay. So I placed the breadboard and I have two components 74808 and 7486, and I placed that in the breadboard now. But before we go into the connection, we want to know how the gates are present inside our ICs. So we should know the internal connection. So if I go for IC7408, which is AND gates, let me see the internal connection. So this is how we have our internal connections. So in the previous video, we have seen only this one AND gate operation. So in a single IC, we are going to have around 4 different number of AND gates. So 1, 2 are going to act as an input, and pin number 3 is going to act as an output. Similarly, 4 and 5 are going to act as an input for the second AND gate, and pin number 6 is going to act as an output. Likewise, we have the third as well as fourth gate. And pin number 4 is going to act as a supply, and pin number 7 is going to act as a ground. So we need to verify this is an AND gate operation. And similarly for XOR gates, so for XOR gate, the same way, the pin number 1 and 2 are the inputs, and pin number 3 are the outputs, and 4 and 5 are the inputs, and pin number 6 are the output. Some gates are very similar. Some gates, the pin number, the input and output may get changed. So here for our cases, both the AND gate and the XOR gate internal pin number operations are same. So what we should remember, we should have pin number 1 and 2 are input and 3 as an output. So with this logic, we'll go for our internal connection. And as I mentioned that we are going to see about half adder using basic gates. Let me see how the experiments are. So this is the design of a adder as well as subtractor. So the first part we are going to see about half adder using basic gates. So AND gate as well as OR gate. So before we go into the circuit connection, we should remember the pin numbers. If we know the pin number only, we can able to give the right input to the right pin number as well as the right output to the right pin number. So what I said, pin number 1 and 2 are going to act as an input for the first AND gate or first OR gate, that is XOR gate. And pin number 3 is going to act as our output. So we'll take the common input A and B input are shared to the AND gate as well as XOR gate. So the output of the XOR gate are taken as a sum, and the output of a AND gate are taken as a carry. So in the OR gate, we are going to add two inputs and we have only a single output. But here it's an addition process. So when we add two number, we may get the sum as well as carry. For example, if I add 20 plus 20, which means that 0 plus 0 is nothing but a 0, 2 plus 2 is nothing but a 4. So I got the answer as a 40. But if I add 50 plus 60. So what does it mean? 0 plus 0 is nothing but a 0, but 5 plus 6 is nothing but a 11. So 11. So below the value of 5 and 6, I have given the value as a 1, that is a sum, but I have remainder as a 1, that is your carry. That carry has been placed by the next left side of the 1. So what is the answer? 1, 1, 0. So likewise, first we are going to have the sum value. In some cases, I'll be having the value as a carry. Okay. Now we're going to see these operations in our using our virtual lab. Okay. So now we placed our AND gate as plus XOR gate. What's the first thing we have to do? First, we have to give the supply connection as well as ground connection. What is the supply number? It's a pin number 14. And we should remember the other operation also, that how the pin number flow goes. That's very important. I'll start from here. For example, here we can have like a small notch, like, or somewhere in dot also will be represented. So from there, the pin number 1 starts and the flow are like 1, 2, 3. So in this way, we are going to come down, and on the other side, from the bottom to the top right, we are going to move up. So 1, 2, 3, 4 up to 7. On the other side, 8 to 14. So this is how we are going to have your pin order number. Okay. So first we are going to give the power supply to pin number 14 and the ground supply to the pin number 7. So where the this is like a dot as with a small notch like a symbol here. So this only with this identification we will come to know the where the pin number starts. So here we have the pin number 1, 2, 3, 4 up to 7, and this I'm going to have 8, 9, 10 up to 14. So first we have to give the supply. So for supply, I'm going to choose plus 5 volt. So just click on to this plus 5 volt and just drag it and place it directly to the location of pin number 14. Yes. So similarly, for the next IC also, I should place it from supply to pin number 14. You can place it anywhere. Hope you all aware about the Intel breadboard connection. So now I've given the supply. Now let me go for ground connection. So COM represents a ground connection that is given to pin number 7. So I'll repeat it. Plus 5 volt given to pin number 14 of AND gate as well as XOR gate. Similarly, the common connection, that is a ground, which is given to pin number 7 in AND gate as well as XOR gate. Okay, now the supply and the ground connection are over now. Now we have to see our circuit one more time. So how is the circuit? How many number of inputs you have taken? We have taken 2 number of inputs, and that is given to pin number 1 and 2 of XOR gate as well as 1 and 2 of AND gates. So here we have 2 inputs. So we'll take the first input and place it at pin number 1. Just drag it. And similarly, second input that is given to pin number 2. Okay. What is the output of AND gates? AND gate output is nothing but a carry. You can see in the output LEDs, the short name represent like S as well as C. So C stands for carry and S stands for sum. So this is a carry operation. This is AND gate. So I'm going to give the carry C to pin number 3. So now we have completed this AND gate connections. So we have given the A input and B input to pin number 1 and 2 of AND gate, and we have given the output of AND gate to the carry. Now this AND gate is nothing but a multiple operation. Now we are going for the XOR gate operation. The same way I'm going to give first input to pin number 1 and second input to pin number 2. What is the output of XOR gate? It's a sum. So I'm going to give this S symbol output to the pin number 3. So this is how we'll be giving our connection in the hardware trainer kit. The same way we are doing that in a software virtual lab. So we'll recall it. I've given the plus 5 volt supply to pin number 14 of AND gate, that is IC 7408, and XOR gate IC 7486, and the COM, that is the ground connection, given to pin number 7 of both AND gate as plus XOR gate. And we are going to have a two common inputs that is given to pin number 1 and 2 of AND and XOR gate, and the output of your AND gate is nothing but a carry, and the output of XOR gate is nothing but a sum. So hope you have given the connections rightly. While dragging the wire, if I place somewhere wrongly, it will notify us. For example, now I'm taking a wire. If I place somewhere wrongly, it won't take into account. So in this virtual lab, they have designed that in such a way, wherever I'm going to place the input, it will accept it. If I'm going to place somewhere wrong connection, it will remove automatically. So that is a plus advantage we have here. Now we'll go for the run operation now. So here we have a start. Now give this start connection. Okay. So here these two inputs are like a switch. Okay. So if I change the switch, now both the switch values are 0, 0. Okay. If I change any one of the inputs, like, so now it is turned to red color, and this is also turned to red color, right? So likewise, I'm going to change your inputs now. Okay. First I'll have this as both the inputs as a 0, 0. I will go for the truth table. What is the truth table? If I'm going to have both the inputs are 0, 0, the outputs are 0, that is some value is 0, and carry are 0. If I'm going to have the inputs as 0, 1, okay, so if it is a carry represents AND operation, sum represents XOR operation. If I multiply 0 into 1, what is my carry? 0. If I add 0 plus 1 is nothing but a 1. Similarly, next third set of input like a 1, 0. If I add 1, 0 means the sum is 1. If I multiply 1 into 0, and the carry is nothing but 0. When I add 1 plus 1, when I add 1 plus 1 is nothing but a 10 operations is like. So when I add 1 plus 1 is nothing but 10. Okay. So 1 plus 1, that 0 goes to the sum, and the 1 is been brought to the carry, and the 1 value is been brought to the carry. I'll repeat it. So here it is all normal operation, but when I add 1 plus 1, which means that it is a 10. Okay, so that 0 is nothing but the sum value, and that 1 is been taken to the carry. Now this is what we are going to verify with our truth table now. Okay, so first time we have it as a 0 as plus 0. If I give a start, is there any output? No. See the output? For 0, 0, the sum and carry are 0. And what is the next input? 0, 1. For 0, 1, sum is 1 and carry is 0. So I'm going to change one input as a 0, 1. First case is 0, 0. Next is 0, 1. So I change the B value as a 1 and give a start. Now you can see the sum which has been glowing into a red color, and carry value is a 0. And similarly, now I'm changing the input to 1 and this as 0. Again give a start. So this is also a sum as a 1 and carry as a 0, because carry is a multiple operation. If I multiple this 1 into 0, the carry becomes 0. And for XOR operation, if any one input is high, the output will be a high. So for XOR, if here we have one input as a 1 and the other input as a 0, so my sum value is nothing but a 0. Now I'm going to change both the input as a 1, which means the sum is going to be 0 and the carry is going to be 1. So after giving the inputs, every time I have to go and press the start. So when I press the start, now the outputs have been changed to sum value as a 0 and carry value as a 1. So for 1 and 1 inputs, sum is 0 and carry is a 1. So here we have seen about half adder using basic gates. So this is how we will be performing using in a hardware circuit also. So the hardware will be taking all the hardware and placing the, so we'll be taking all the wires from the supply, from the inputs as well as from the outputs. But using virtual lab, the same way we are doing, but we are going to just drag the respective component and we're going to give a connection. Thank you.